Assalamu alaikum Pakistan. कैसे हैं आप लोग? I'm sure that a lot of you would have seen the introductory video that I shared before the event. So today I would be talking about security and security especially for Kubernetes clusters, and my talk is titled From Perimeter to Zero Trust: Securing Kubernetes with Paralus. My name is Atulpriya Sharma and I go by the handle @TheTechMaharaj on Twitter. I work as a developer advocate at Infracloud Technologies, and I create content around cloud native, Kubernetes, and DevOps. I'm also a contributor to many open source projects and a maintainer at Paralus, which is one of the most recent CNCF sandbox projects. When I'm not working, I can be found at a restaurant eating something or traveling across the country and exploring new places. So you can reach out to me at my handle on Twitter, you can reach out to me on GitHub, and also at my mentioned email ID. So let's get into the agenda of the talk. I would be talking about the evolution of security in general. We would then delve into what Kubernetes is today, how it was earlier, the various security mechanisms, the pitfalls of native mechanisms. After that, we'll get into zero trust, which is the topic for today. I would talk about what is zero trust, the principles of zero trust, implementing zero trust in Kubernetes, why it is difficult. We'll then talk about Paralus, what it is, the features of Paralus, and we'll also give you a quick hands-on demo using Paralus. We'll also show you how you can be a part of Paralus and contribute to the project. So I'll start by talking about security in general, and we'll just give you an overview of how things have evolved over the years, including the threats, the technologies that we use, and also the policies that are around security in general. Talking about the evolution of software security, I would first like to focus on how the threats evolved over time. So, initially we had floppy disk, which was the only medium to transfer data between computers. That was before the internet. So we had floppy disk where the viruses, trojans were used, were transmitted using floppies. Then the internet era came in, and we had a huge boom of phishing attacks, which are even quite popular today as well. We also have the distributed denial of service attacks, which have become quite common. We have advanced persistent threats, which are threats which go beyond boundaries, beyond geographies, as well as they are quite complex in nature. We then had IoT attacks where we saw that devices being hacked, like CCTVs, cameras, and even cars remotely. And we also have ransomware as a service today. So these were the threats, how it evolved. And to counter the threats, we also have to evolve our technologies as well. So, we started with simple password-based mechanism, which is actually the first line of defense. We also had antivirus softwares, which were there to deal with the worms and trojans. Later came in the firewalls, which were the basic principle behind the perimeter-based security. And these firewalls became quite popular amongst the enterprise to protect their internal devices in the infrastructure. The next advancement was the intrusion detection and prevention systems, which alerted the admins whenever an intrusion happened. And we then had the security information and event management systems where it would collect security incidents from across the system and give data to the admins for them to take action. In the current age that we are in, zero trust is the gold standard of security, and I'll talk more about that when we get into the presentation. And the third thing which also evolved over time along with threats and technologies were the regulations. So initially we had the HIPAA regulation, which was more around dealing with patient data and health records. We had the Sarbanes-Oxley regulation, which was in 2002, which was aimed towards handling of sensitive financial information and regulation. And also a couple of more recent additions to it, the GDPR and CCPA, which are more towards the privacy orientation and regulation. So this is how generally software security has evolved along with the threats and regulations. Now let us talk about Kubernetes. So Kubernetes, as we all know, has become the operating system of the cloud, and it is the largest and the most widely used container orchestration platform. Now in the next section, what I'll talk about is how Kubernetes evolved over the years and how security became a talking point for Kubernetes and how they implemented the various features that we see in Kubernetes today. So talking about Kubernetes in the early days, we all know that it was the year 2014 when Google actually open sourced and donated Kubernetes to CNCF. So back in the day, the focus was mainly on the core features of Kubernetes, and the basic security mechanism that was in place was the perimeter-based security. So the developers of Kubernetes felt that it's important to improve the core features, and in terms of security, the existing firewalls would be enough for anyone to protect a Kubernetes cluster. But as we saw that the threats also evolved, a couple of years down the line, the team realized that security was becoming a concern for the project, and that was because it saw a huge adoption. That's when the Kubernetes security project was found, and the whole focus of this project was to improve the security of Kubernetes and give some native mechanisms that can help improve the security. So they came up with the role-based access control, which is one of the most common and preferred ways to protect anything in your Kubernetes cluster. So we define roles, we define users a particular role, and then that's how you manage access. There were also network policies which allowed us to configure the way the traffic moves between the clusters, within the cluster and also from outside to inside the cluster. We also had admission controller, where it basically allowed us to create some rules in place and policies, and based on that we were able to perform certain actions and allow different users and devices to access our cluster. Now, when we talk about the native Kubernetes, security mechanisms in place, we already discussed about what RBAC was, and similarly, we discussed about network policies. So I would focus a bit more on the pod security policies. So these type of policies, what they do is they actually define the security requirement for running a pod. So for example, let's say you create a policy that requires all the pods to run as a non-root user. Now this is a pod security policy. So what this will do is that all the pods that will run, it will enforce a policy that anything that is running within the pod, it has to run as a non-root user. So the next mechanism is encryption of sensitive data at rest, and Kubernetes supports encryption of various sensitive data at rest. So you talk about secrets, you talk about various configuration data. It is encrypted at the base ground level, and using technologies like HCD encryption and using various key management services as well. The next mechanism that I would like to discuss is the monitoring and audit logs. So as we all know that the major interaction with a Kubernetes cluster happens through the API server, and all the API requests that go through the cluster and all the events that happens within a cluster are actually monitored and audited by the Kubernetes as well. And this information can be used for auditing, forensics, incident response, incident management, so on and so forth. One of the interesting features from the security point of view that Kubernetes has, that I personally felt quite important, are the authenticator plugins. So what basically it does is that since you interact with the API server, Kubernetes give you options to encrypt that part as well. So you can use JWT tokens, you can use OAuth based application, you can even use 509 certificates and encrypt that part of communication as well, and also add an additional layer of authentication before sending in any request to the Kubernetes cluster. And lastly, there are dynamic admission controllers. So these controllers are basically components that enforce security policies based on some events related to some resources. So let's say a particular controller is created to enforce policies that require all pods to run with some specific security context. Now this is an admission controller, so whenever a pod will be created, it will ensure that this particular policy runs with it. So these were some of the native security mechanisms that is present in Kubernetes, and all of these, or a group of these or a mix of these is used by the enterprises, by various groups to secure that Kubernetes clusters. Now, while the native mechanisms are very good for protecting any Kubernetes cluster, whether it is pre-prod or even production, there are a few pitfalls which are associated with these mechanisms, and I would like to discuss those. The first one being lack of comprehensive coverage. Now, we spoke about RBAC in the earlier section. Now, what happens is that when Kubernetes provides RBAC to control access to resources, but then this is limited to everything within the cluster, but it does not have any security to protect against, network level attacks, like, if DDoS or something happens. So in such cases, it will rely on something like a firewall, or on something like an intrusion detection system. So that comprehensive coverage is in a way missing in the native mechanism. Also, there is a limited visibility. So for example, what happens, Kubernetes does not provide a built-in mechanism for monitoring the traffic, which is actually happening between the pods or within the cluster. So if there is any unauthorized incident that has happened, and there is an access, or there is a user within the cluster, then it would be very difficult for Kubernetes to actually detect this unauthorized access or whatever malicious activity that is happening. Also, the configuration is quite complex. For example, if you want to configure a Kubernetes network policy to secure, let's say, the network traffic within the cluster, it's complex because you need to understand how the entire Kubernetes cluster works, especially from a networking standpoint of view. Which can get really cumbersome, especially when you have a lot of pods and the application is quite large and complex. Also, there is no real-time threat detection as of now. So Kubernetes does not have any built-in security tool for detecting and responding to any security incident, especially in real time. So if you want to detect some malicious incidents, or you want to block something in real time, that's quite not possible with the native mechanism. And also, the auditing logs which is present is quite basic, and doesn't provide much valuable data when it comes to actually protecting your Kubernetes cluster. Now that is where you need something that actually gives you a more comprehensive way to deal with security, and a better way to protect or safeguard your Kubernetes cluster. And that's where actually zero trust comes in. So it gives you comprehensive security and comprehensive coverage, and what it also does is that it gives you increased visibility. So zero trust essentially enforces that a lot of logging is done, a lot of events data is being collected, a lot of auditing is done. So you have a lot of data with you on which you can take actionable insights. You can even build models to take some preventive approach. And also what zero trust does is that it is quite an easy and a simpler way to implement. It's easier to implement considering all the native mechanisms that we had. Now, while I told you why zero trust is needed, but I didn't tell you what zero trust is. So let us look into what zero trust actually does. So zero trust is a term was coined by John Kinderwag in 2010. He is a security researcher, and the whole idea of zero trust was that you verify every request and don't rely on any device or any user within the network. So verify every request explicitly, and it doesn't rely on network segmentation or firewalls. So firewalls are the past, and zero trust is what is the present. And moreover, a lot of people think that when we implement zero trust, it's more about the technology itself, configuring the permissions, configuring the roles, networks, etc., etc. But I feel that there's a lot of processes also involved in it. You need to have fixed and correct processes in place to ensure that you take full advantage of zero trust. And also you need to train the people who are using systems that are running zero trust, and also the administrators who are administering, or rather managing the infrastructure where zero trust is implemented. So it's important that all three people, processes, and technologies are in line. And lastly, it has become a gold standard today when it comes to security. So talking about principles of zero trust, there are quite a few. So when you Google, you will find a lot of principles, and some of them will be a part of what you see on the screen. So the first one is that it's based on the principle of least privilege access. So you want to ensure that access to sensitive data and application is granted only on the basis of least privilege access. So it means that any users who is granted any permission, you want to ensure that it's the minimum level of permission. So let's say you have a user and you are granting some access to data, make sure it's only read only, and you don't want to give them a right on a right access to it. Also, we talk about verifying every request explicitly. So anything that comes in, you want to ensure whether it's a device or a user inside or outside the organization network is always untrusted. That is, don't trust them explicitly, and then you verify each and every request that is coming in. So that's pretty much about verifying explicitly. We then talk about micro segmentation. So what zero trust does is that it creates isolated security zones within an organization networks, and what that does is that it helps to limit the damage. So even if something some malicious activities happen within a particular network, that will be contained only to that particular segment, and it will not be transmitted to other segments of the network, thus protecting the overall setup. Also, one of the principles is continuous monitoring, like I mentioned earlier as well. So, zero trust includes continuous monitoring and real-time analysis of network traffic, and it, also detects and responds to any suspicious activity as well. And just like the Kubernetes native mechanism, it also provides end-to-end encryption of the data at rest as well. Now, these were the principles of zero trust. Now, implementing zero trust is a collection of a lot of things, like I discussed earlier. It's the technology itself, it's updating the processes, and it's also about training your people. So, you essentially start by defining the security requirement of your organization or your team, what you want to achieve, by implementing zero trust. So you need to define that first, and once you have that in place, what you do next is you actually implement the network segmentation. So this is where you actually try to segment the network and make sure that you have the right segments in place, and if anything goes wrong, it doesn't spread to the entire network. So accordingly, logically, you will just figure out how to segment your entire network. What you do next is you implement role-based access control. So you create roles based on the organization structure, the team structure that you have. So you create role-based RBAC policies for them. You also implement end-to-end encryption of all the data that is happening, and also the traffic and also the routes within the cluster as well. So you want to ensure that anything that goes in the cluster, what's roaming within the cluster, is also encrypted. Add a layer of security by enabling multi-factor authentication. So you can enable things like OTPs or time-based or OTPs that we have to add an additional layer for users. We need to implement continuous logging. So you need to ensure that all the actions that are performed by a particular user, a particular device within the network is actually logged. And lastly, once you have done all of this, you want to ensure that your employees are trained as well. So they need to understand why zero trust was there, what's the benefit it's going to get into the system, and how it is different from a traditional approach. So once your employees are trained, then it will be easier for you to implement this at scale, and everyone would be finding it easy to use it as well. Now, while you see the steps and it looks quite easy and straightforward to implement it, the major problem happens when you have to implement all these things to hundreds of clusters, and when you have a very large team, especially which is scattered across the globe. Now, manually doing this for all these clusters is a very tedious task. Moreover, more than being tedious, it's a very error prone task, because if any configuration goes wrong anywhere, you have a huge security risk in that place. So to avoid such situations, it's better that you have some tool that can do this for you, and that's exactly where Paralus comes in. So Paralus is an open source tool that enables controlled audited access to your Kubernetes infrastructure. So it has zero trust principles baked in. So what it does is that since it has zero trust built in, so you don't need to do any additional steps to protect your infrastructure. It just comes with it, and it has a very intuitive UI that allows you to interact with it. You can interact with it even with the CLI. You can even use the APIs as well. I will show you how that happens. And as I said, this is an open source project, so you can check it out on github.com. Paralus is the repo. The entire developer documentation is available on our website, paralus.io. And if you're interested to interact with the community, have any doubts, you can join the Paralus Slack channel, which is on the Kubernetes Slack. So now I'll talk about the features of Paralus, and I think one of the most important feature that I need to talk about is the firewall access. So what Paralus does is that it does not want you to configure any ports within the firewall. So you don't have to open any ports for Paralus to work. The Paralus is built in such a way that without that it is able to communicate with your cluster. So that's the one biggest benefit of using Paralus. What it also does is that it allows you to create custom roles, users and groups. So there are a certain list of permissions and roles that are given. So you can mix and match and create your own role based on your requirement in the organization. What it also brings to the table is dynamic and immediate changing and revoking of permission. So, the moment you remove permission for a particular user or a group, it will be invoked almost instantly. It also provides seamless integration with identity providers. So you talk about Google, Microsoft, Okta, it works seamlessly with them. So the last feature of Paralus that I want to discuss is automatic logging. So what it does is that it creates logs for all the events that is happening within the cluster. So be it API request or all the requests which the admin or any user has done within Paralus. So it will create an audit trail for you so that it becomes for you to rectify an issue or find through an audit trail which can help you in investigation a particular issue. So let's now move to the most exciting part of the talk. That's the hands-on demo. To save time, what I've done is I have recorded a few things for you. So what I'll do is I'll play that and help you understand how Paralus actually works. So installing Paralus is quite easy and straightforward. So it uses Helm package manager. So we have a Helm install command that we run and Paralus is installed. So what I'm doing now is I'm running it on a DigitalOcean cluster. So the first and foremost step is that Paralus uses domain-based routing. So we need the external IP address to configure our domain name system. So I just run the command to get the service for the Contour Envoy proxy that we are using. There's the external IP address. Now what I need to do is I need to go to my domain control panel and add the CNAME record. So I will add 3 CNAME records. One would be console.mydomain.com, similarly star.core connector and star.user, and make sure that it's the same IP for all 3 of them. Now the moment this happens, it takes a while for the DNS to be updated with the IP address. What I'll do is I will also try to generate the default password for the user. So when you install Paralus for the first time, it creates a default password for the user. So once I get the password, I head to console.paralusdemo.com. That's the domain in my case. And I copy the password and log in using the default admin credential. So that's admin@paralus.local and I give the password. So on the first login, what it does is it will ask you to reset your password because that's the basic security mechanism in place. So you provide a new password and then you will be able to log into the Paralus dashboard. So once that is done, you will be taken to the Paralus dashboard and everything in Paralus is organized based on projects. So you will see a default project which is there. What we'll do is we'll create a project. And the first activity that I'll show you is to import a Kubernetes cluster. So while this one is running on DigitalOcean, what I'll do is I'll try to import a Minikube cluster that is running on my laptop locally. So I go to clusters and I click on new cluster and I try to import an existing cluster. So essentially, trying to bring in the Minikube cluster to Paralus, which is currently running on DigitalOcean as I told. So when it comes to environment, I'll choose as data center or edge because it is actually running on my laptop. And the Kubernetes distribution in this case would be other because again, it's a Minikube instance that is running. I'll provide a name for the cluster. This will help me identify the cluster within the Paralus dashboard and the project as well. So I'll give that a name. In terms of configuration related to network, we will just leave it as is and move on, continue. So what it will do now is it will ask me to download a bootstrap file, which is basically a configuration file that allows Paralus dashboard to communicate with your cluster that we are importing. So I'll just download that and just keep an eye on the registration status. So currently it shows registration pending. What I'll do now is once the file is downloaded, I'll simply use kubectl apply F and apply that file to the cluster that I want to import. So the moment I do that, I will see that a lot of CRDs have been created. So you can just check that, config maps deployments are created and we have a relay agent that is configured there. So the moment I, run, I can check whether the relay agent is running or not. So if I run that, status is running and immediately you see that the check-in is complete. So once that happens, what we have done successfully now is that we have imported a Minikube cluster that is running on my laptop to Parallus, which is running on DigitalOcean. So I can, similarly bring in clusters from anywhere. I can get it from AWS, EKS, GKE, wherever the clusters are, I can bring them to Parallus in a similar way. There's also the kubectl command. So I can run kubectl commands from the browser itself. So, you see here, so I just give a kubectl get namespaces, and it will list all the namespaces which is there in the current minikube cluster. So let us try to create a namespace, and let me try kubectl ns orange. So a new namespace orange is created. Let us go ahead and validate that. So if I go to my local cluster and run it, if I give kubectl ns, and I will see that the orange namespace is created. So that's one use case. We imported a clusters. Like I said, you can do it for different cluster as well. Another thing that I would want to show you is that how it easily integrates with identity provider. So we'll try to add a new identity provider here, and we would be using GitLab. So to do that, what we need to do is first go to your GitLab account, and you need to create an OAuth application here. So just give a name to the OAuth application and choose the scopes. So you need to choose some scopes which are specific to GitLab, and all the details are present on our website. So you can go to paralus.io, read our documentation on how to create an OAuth application for GitLab. So once I do that, I get the client ID and the client secret. I simply copy it and paste it in the Parallus dashboard. Give it a name and choose the IDP type as GitLab. Obviously, if you're using anything else, choose from the dropdown, or you can choose generic if it's not present. We give the scopes and the issuer URL. On the next screen, I get is the callback URL, which I'll have to update in the GitLab portal, and also the mapper file which will be there. Now, once I do this, I see that GitLab is configured here. So let me open a new window, log into Parallus demo, and you see that I have a sign in with GitLab now. So the moment I click on it, it will take me to GitLab, where I will log in with my GitLab credentials, and you just see that. And the moment I do and click on sign in, the callback URL will basically come into picture, and it will bring me to Parallus. Now the moment I land here, I see that I have no access here. So it says that you don't have access to any projects, please contact your administrator. So what essentially happens is that the moment the first time any user logs in through IDP, they are not assigned any group or any project by default. So let us go ahead and create a new group. So let us see the IDP user. So the user is created here. We'll go to groups and create a new group. Let us name this group as new group. So we create the new group, and the next step is basically to assign a project as well as add a user. So what we'll do is we'll create an add or remove user, and we'll choose the IDP user. So you see that Gmail ID over here. So we have added that user to the group, and we will do now is we will assign the project as well. So if you remember, we created a new project called local project, where we basically imported the minikube cluster. So I'll choose that project from the select project dropdown. And in terms of role, I will choose the project read-only role. So we want to ensure that this new IDP user who logged in through GitLab has only read-only permissions. So let's just verify that. So we have our new group created. The name is new group. The project is local project, and the role is project read-only. So what I'll do now is I'll go back to the window, which is where we logged in with GitLab and where it shows no access. I'll just refresh it because we have refreshed the permission. The moment I do that, what I see is that the user has been given scope to local project, because that's what project we assigned to the new group. And if you go there, I have the minikube cluster that is already present. Now, if you remember, we have given only read-only permissions. So let us first try to run read-only command. So let us do a get ns. So the moment I do that, it will just show me the list of namespaces present. Now let us try to create a namespace. So the moment I do that, I immediately get a forbidden error, obviously because the permission that is given to this group is only read only. So that was how Parallus actually works. So with that, we come to the end of the demo, and how can you be a part of Parallus? Well, first try out Parallus. You can join our Slack channel. You can fork and star the Parallus repo. Once you use Parallus, you can also raise issues, bugs, and feature requests. You can contribute PRs related to code and content. You can join our community calls, which happens bi-weekly. And you can follow us on Twitter @Paralus_. You can obviously DM your questions to me on Twitter, or you can tweet to me, and I would be more than happy to help you understand more about Parallus. And yeah, that's all I had to talk about. And it was a wonderful time, sharing information about Kubernetes security and talking about Paralus. And once again, thank you so much for having me here. And it was great being a part of the first KCD event. Thank you so much, and Khuda Hafiz.